All right. So far we have been in our chapter number 1, and we have learned about the definition of the economics. We have seen the scarcity, PPF, and the opportunity cost. We have seen why we study economics. And then we move to demand curve, demand, and we have seen the definitions of demand, law of demand, determinants of demand, change in demand versus change in quantity demanded. And then we move to supply in the last class. And the supply, also we have seen some definition of supply, law of supply, determinants of supply, and change supply versus change light. Today we are going to start our 1.4, that means equilibrium, and we'll cover 1.5, that means elasticity of demand and supply. Okay, so let's start our journey, remaining of this chapter 1.4, equilibrium. What is equilibrium? The synonym of equilibrium is called stability. Okay, stability. And stability can be seen in this way. Suppose there is a bowl. Here is a bowl, okay? And there is a marble inside the bowl, okay? And then if you hit the bowl, then it moves to and fro, moving towards this and that, and again come back. And there is a pendulum-like movement, and then finally it gets stability here. Okay, stability. Okay, so this stability is stable. I mean, this stable when you hit the ball or hit the marble. Not that much force that it becomes outside the ball. Okay, so it is up, the stability is up, depends on the force you hit. So this is the idea of stability, or you can say it as, call it as stable equilibrium. But it becomes unstable. I mean, suppose we have made our ball like this, so upside down. Suppose this is a ball now, upside down, and you place a marble here. Okay, so if this is stable state. Okay, so this is stable, but if you hit the ball, it falls down. Okay, so it never come back. It never comes back. Okay, so this stability is called unstable equilibrium. Okay, so this is the basic idea about the stability or equilibrium. So something like a pendulum in physics, those who are from physics department, they know that there is a pendulum. So if you hit the pendulum, then it moves like that. Okay, so this and that. So when it settled down, so finally it settled down, and that is called stability or stable situation. Okay, So in that case, stability is there. So this is the idea of stability, and stability, the idea of stability can be used in equilibrium. Okay. So we can graphically illustrate the equilibrium in this way. So suppose we can use our diagram, PQ state diagram. So suppose this is our P and this is our Q, either QS or QD. QS is quantity supplied and QD is quantity demanded. Okay, so in the last class we have seen that our demand curve is like this. So this is our demand curve and our supply curve is like this. Yeah. This is what we have seen in the last class. Okay. Now the intersecting point is called equilibrium. I mean Q star, and Q star equals QD equals QS. Okay, and in the y-axis there is a P star. That means price and quantity. So P star, Q star coordinates is called equilibrium. And this equilibrium is where demand and supply curve intersects. Now, how can we connect these with the stability concept we have seen in the last slide? Okay, so let's go back to the last slide, and if we see that there is this force indicated by arrow is called, you can call it as shock. Okay, shock or push. So you can think about this shock in here also. So if you give some price shock, suppose our shock is price shock. So price shock means that price can be go up or price can be go down. Okay. So if price is go up, then it is called negative shock, because we don't expect, or we don't want price to be getting higher. So it is called negative shock. And price go down means positive shock, because we want price to be going down. As a consumer, we want price to be going down. So this is consumer's perspective. Consumer's perspective. But this is also, I mean, this is not a producer's perspective, because producers want price to be higher. Okay, so producer's perspective is reverse. Perspective is reverse of consumers. Okay, so suppose we have a negative shock. So what happens? So when there is a negative shock, price go up. What will happen when there is a negative price shock? That means price is now P1. Okay, so price go up. When price go up, you see that there is a demand here and supply is here. Okay, so if price go up, demand is less than supply. Because this is less than supply, then there is a surplus. Because demand is less than supply, the producers are supplying more than the consumers are demanding, so there is a surplus, and this surplus has some force. So this surplus has some force, okay, and this force is forcing the price downward. Okay, so price will come back again P star, downward to P star. So there is a negative shock, and for that reason surplus is there, because supplier is producing more of good X than the consumer demanding less, because the price is higher. So this portion is called surplus. Surplus in the market. And this has downward pressure. So surplus has downward pressure on price, and negative shock wiped away. Negative shock disappears. Okay. Now, what about if there is a positive shock? That means price is now here, P2. Price is now here. So if price is here, then you see that because there is a low price, price is now down. So demand is more than supply. Okay, so demand is more than supply. Why? Because you see that when prices go down, producers are supplying less because price is lower. They don't have any incentive to supply, but the demand, those who are demanding, they demand more. Okay, so that much. So there is a gap, and this gap is called deficit. Okay, so we can mark this as deficit. And this deficit has got upward pressure. Previously, we have seen downward pressure. So this deficit has got upward pressure. And this upward pressure is on price. And price goes back to the original situation. That means P star. So when there is a price shock, positive price shock, then P2 remains for some time, but goes back to original state. Similarly, when price has negative shock, then price go up and again it returns. So P star is our equilibrium price. So now P star is called, that's why P star is called equilibrium price. And Q star is called equilibrium quantity. So this is the idea, and this idea depends on when QS equals QD equals Q star. So remember this equation. Okay, so let's move to the second point, 1.4.2, and that is mathematical model of equilibrium. So how do you explain mathematical model? So suppose we have seen in the second class that our QD is A minus BP. Sorry, let me wipe out eraser here. So here, so that is equation 1, and QS, we have seen that QS equals C plus dP. That is equation 2. Can we find equilibrium? Find equilibrium P star Q star. We can solve this equation. So we know that at equilibrium QS equals QD. Okay. So if we make this statement, then we can say that A minus BP equals, this implies A minus BP equals C plus dP. So we can say that A minus C equals BP plus dP, or it is equals, you can take P as common, then B plus D. So P star is equal to A minus C divided by B plus D. Okay, so now what is Q star? So Q star equals, so put P star in any of this, now put P star in any of this above equation. Then we can get that Q star is equal to A minus B, A minus C, B plus D equals A minus AB plus BC. Okay, divided by P plus D. Then we can take B plus D, AB plus AD minus AB. Let us do something here. Okay, so minus AB plus BC. Then AB cancel out. So here AD plus BC divided by B plus D. So this is our Q star. Okay. Let me check if this is all right or not. So suppose we are taking QS equals C plus D AD plus BC divided by, oh, sorry, this one is A minus C divided by B plus D. Then it is equal to C plus AD plus BC. Oh, sorry, it is minus AD minus DC, B plus D, BC plus DC plus AD minus DC divided by B plus D. So DC and DC cancel out. So finally we get BC, AD plus BC divided by B plus D, which is equal to Q star. Okay, so this is cross check. This is called cross check. Okay, so we have found that cross check. By cross check, we have found that this equation is all right. So we can say that equilibrium is like this. Okay, so A minus C divided by B plus D, and here AD plus BC divided by B plus D. So this is our equilibrium price and quantity. Okay. So okay, we have seen that there is an equilibrium price and quantity here, and equilibrium price is A minus C, and A minus C over B plus D, and equilibrium quantity is AD plus BC over B plus D. Okay, so this is our model. So we have seen our model here. Now we can take some example as a numerical example. Suppose QD is 8 minus P, and QS is what can I say, 10 plus 2P. There is a problem here, so maybe it could be minus 10, then we'll get the real result. Remember, our equation was QD equals A minus BP, and QS equals minus C plus DP. And C could be either 0, C could be positive, C could be negative. So you can get a negative here. Okay. And then we can do some calculation here. So 8 minus P equals minus 10 plus 2P. So 3P equals 18. So P star equals 6. Q star equals 8 minus 6 equals 2. So you can verify this in supply curve also. So QS equals minus 10 plus 2 times 6 equals 12. So then which is equal to 2, which is equal to Q star. Okay. So in this way we can find price quantity combination, and you can say that it is 6 and 2. Okay. So here there is a condition P and Q both are positive, because price cannot be negative. Okay. Negative price is not possible. Also, negative quantity is not possible, is absurd. So when there is no minus sign here, so when there is no minus sign here, we get some negative point. Okay. All right. So we understood equilibrium clearly. Now let's move to the graphical more graph in equilibrium. So suppose we have got some demand and supply. So this is our demand and this is our supply. And now what will happen when one of the curves shifted? Shifting of demand or supply curves. So suppose for some reason, the reason may be various. So suppose there is a shift in demand curve. So originally your Q star is here and P star is there. So when there is a shift in demand curve, so suppose this is D0 and this is D1. Okay. And supply curves remain the same, S0, S0. So what will happen when there is a shift in demand curve? Your quantity demanded will increase. Q0 star will now Q1 star. Okay. And price also increase. So P star also, P0 is now P1 star. So for that reason, quantity increase means price increase. Okay. So this is called change in quantity demanded here change in price. Okay. Similarly, if there is a change in, I mean, there is a shift back. So this is forward shift. So there could be a backward shift. So when there is a backward shift, quantity Q2 star is going back and P2 star is going down. Okay. What about the supply case? So suppose your demand curve is this, D0 is now fixed. Your supply curve is shift up. So this is your supply 1, supply 0. And originally it is Q0 star and P0 star. So when supply curve shift up, then our new equilibrium is here. So Q1 star and sorry. No. Sorry. This one is our new equilibrium. This one is our new equilibrium, and our new price is here. So it is P1 star. So when supply curve shift back or shift up, when supply curve shift forward or shift down, then what happens? New equilibrium quantity is Q2 star here, and new price is P star 2 here. Okay, so this can be said that graph for shift in supply or demand curves. Okay, and this can be written as shifting of supply curve. And this is shifting demand curve. Okay. All right. Now let's move to the second part. I mean, 1.5, elasticity of demand and supply. So what do you mean by elasticity? So elasticity is measuring what? Strength, right? As well as the depth of the relationship. Okay. So in our economics, we have studied the relationship, right? So what was the relationship? We studied the relationship between QD is a function of P ceteris paribus. We have seen that there is a relationship between, that means this indicates the relationship between price and quantity. Okay. Similarly, QS is a function of price, P, and QS. So this is how we express demand and supply. So this is simply relationship, but we can't understand from this two functional equation how strong or how deep their relationship. So in order to understand the depth of the relationship, we need to understand the concept of elasticity. Okay, so this is the background of the study of elasticity. So we can define elasticity. We can define elasticity as epsilon. Epsilon is equal to percentage change in dependent variable divided by percentage change in independent variable. So here in our demand case or supply case, dependent variable is QD, so we can write in this way. So this can be written as percentage change in QD or QS divided by percentage change in P. Okay, and this can be written as del QD divided by Q and then whole divided by del P divided by P. Okay. All right. So why? Because we know that percentage change is some change in variable Q divided by Q times 100. And here you see that both 100 and 100 is cancel out. So we can write in this way. So again, we can do some manipulation and then we write del QD divided by del P times P divided by Q. So this is our basic formulation of elasticity. So we can write in this way. So elasticity equals del QD or QS divided by del P times P divided by Q. Okay, so this is our fundamental equation for elasticity. Okay, so what does it mean actually? So by elasticity, so here this is elasticity of demand and elasticity of supply is del QS del P times P divided by QS QD. So what is the meaning of that? The meaning is that for 1% change in price, what is a change in quantity demanded or supplied? So that is the meaning of, literal meaning of elasticity. So meaning of elasticity. So what is the meaning of elasticity? Meaning of elasticity is for 1% change in price, what is going on in change in quantity demanded or quantity supplied is called elasticity. Okay, so this is the basic idea of elasticity. So we are measuring the depth of the relationship between price and quantity. That's it. Okay. All right. So next point is, so it is already done, definition of elasticity. Okay. So next point is types of elasticity. Basically, we have got two types. Actually, it is two forms of elasticity. So one is called arc elasticity. So in arc elasticity, elasticity is del Q, del P, P divided by Q. So this is arc elasticity. And in point elasticity, this is form number 1. Form number 2 is called point elasticity. Okay, so point elasticity is just here. You see that change in quantity and change in price are substantial. So here we see that there is a substantial change. How we can see that substantial change? So if we say that our demand curve is this, so here there is a change in price and change in quantity at point A and B. So this is Q0, Q1, and this is P0, P1. So this portion is called change in price, and this portion is called change in quantity. Okay, so here this is actually slope of the demand curve, and slope is multiplied by the price quantity ratio, then it becomes elasticity. Okay, so this slope is visible, so you can see this change in price. So change in price and change in quantity is visible. So when visible, then it is called arc elasticity. But sometimes the change is not visible, so we transform this into calculus form. So here we see that there is no, there is, suppose same demand curve, but take a point. So suppose there is a point A. So in A, we can apply the infinitesimally small change. Okay, so change in price tends to 0. So when tends to 0, change in price tends to 0. Okay, a very small change in price. Quantity is also tends to 0. So we can apply this equation by calculus that elasticity is now equal to ddx, dq dp times p divided by q. So this is the derivatives. So for p tends to 0, that means very small, infinitesimally small change. For infinitesimally small change in price, what is the change in quantity demanded is called point elasticity. Okay, it's called point elasticity. So we have got two forms of elasticity. Now let's move to the types of elasticity. So there are 5 types of elasticity. 5 types of elasticity. So we are going to illustrate one by one. Okay. So number 1, the first elasticity is called unit elasticity. So what is the unit elasticity? So when elasticity is equal to 1. percentage change in quantity is equal to percentage change in price, then elasticity is equal to 1. So what is the meaning of that? Meaning of that is that for one unit change in price, quantity changes by 1 unit. So elasticity is equal to 1. So this is called unit elasticity. Number 2 is called elastic. When percentage change in quantity is greater than percentage change in P, percentage change in quantity is greater than percentage change in Q, then because we know that elasticity here, you can write down again. So elasticity is percentage change in Q divided by percentage change in P. So this equals, that means elasticity 1. So here elasticity is percentage change in Q, percentage change in P. So this is greater because of that. Okay, so this is called elastic. Third one is called perfectly elastic. So what is perfectly elastic? When elasticity is infinite. So one is that. So when so suppose elasticity is equal to percentage change in Q, percentage change in P. So this figure becomes elastic when there is a percentage change in P is equal to 0. So anything divided by 0 is infinite, right? So the definition of perfectly elastic is that, so we can define here, when for a price tends to 0, change in price tends to 0, then elasticity is percentage change in quantity divided by 0, means elasticity equal to infinity. Okay, so we have got 1, 2, 3. So we have done this one and part of this one. So let us do it here. So fourth elasticity is called inelastic. And inelasticity is when this is less than 1. Since more than 1. Here there is infinity. So we can call it as elasticity is more than 1. Okay. So when elasticity is less than 1, what does it mean? Or it means that elasticity equal to percentage change in Q divided by percentage change in P, and this is less than 1 when percentage change in Q is less than percentage change in P. Okay, so when this is the case, then elasticity is less than 1. And what does it mean actually? It means that for 1% change in P, that means price, there is less than 1%, less than 1% change in Q. Okay, so this is called inelastic. Number 5th is when perfectly inelastic. That means elasticity is equal to 0. And we obviously know that when it is 0, so when elasticity is percentage change in Q divided by percentage change in P is 0, when it is possible, then because percentage change in Q is equal to 0. That means for any change in P, if there is almost no change in quantity, that is called perfectly inelastic. We can show them graphically. How we can make a graphical, suppose we are dealing with epsilon equal to 1. So elasticity equal to 1, we can draw graph here. So suppose we are dealing with demand curve. So suppose this is change in P, and if I say that this is also the same distance is also change in Q, so Q, we can get a point here, a point there. If we connect this 2 point, then our change in Q is equal to change in P. So here you see that there is a P0, P1, Q1, Q0. So this is elasticity is equal to 1. What about elasticity is greater than 1? So we have seen that elasticity is greater than 1 when change in P is less than change in Q. So suppose change in Q is this. Okay, so here you see that there is a point here, point there. So here del P is equal to del Q. There del P is less than del Q. So that's why elasticity is greater than 1. So this is 1, this is 2. Again, we can see that there is a change in price, but change in Q is very small. So here you can produce a Q point here and point there. So there is a change in P is greater than change in Q. So elasticity is less than 1. Okay. So this is slope depends on the slope. Slope is flatter, steeper. Okay. And when this is elasticity number 3, when elasticity 4, So let me see the, okay. Oh no, this is actually 4. What is 3? 3 is when there is a del P is almost 0, but there is a del Q. Del Q. So here elasticity is equal to infinity. Okay. This is 4. Why infinity? Because there is a del P equal to 0. Del Q is something. So elasticity infinity. What about 5? Number 5. When there is a vertical demand curve or supply curve, then del Q is 0, del P is there. So here elasticity in that case, this is called perfectly elastic, and this is called perfectly inelastic. Epsilon is equal to 0. Okay, so this is the graphical representation of arc elasticity. Okay, we can show them graphical representation of point elasticity. How? Suppose this is our graph, demand curve, and for point elasticity, remember, for point elasticity, slope, suppose QD is a function of P, and there is a slope. Okay, so slope is del Q del P. So slope remains constant, or first derivative of this dq dp, it is constant. So if this is constant, then we can change our P divided by Q ratio changes. Okay, so take the midpoint. If it is the midpoint, suppose midpoint is our A. So in the midpoint, for point elasticity, the elasticity is equal to lower segment divided by upper segment. So what is the lower segment? Suppose this is point B and this is point C. So for A, point A, lower segment is, so lower segment is AB for point A. For point A, lower segment is AB. Upper segment is AC. Okay, so here you see that elasticity is lower segment divided by upper segment. That means elasticity equal to AB divided by AC. And because AB is equal to AC, that means midpoint. So elasticity equal to 1. So at the midpoint, elasticity is equal to 1. So what about point here? So suppose there is a point E, A, B, C, D, A, B, C, D, so D. So we can say that at point D, elasticity equal to upper segment means dB, lower segment means dC. Okay, so elasticity is upper segment dB divided by lower segment dC. So sorry, elasticity is lower segment d is equal to dB divided by upper segment equal to dC. So we can say that this is, I mean, because dB is less than dC, so we can say that elasticity is less than 1. That means inelastic. Okay, so this is true for any point between. This is true for any point between A and B. So we can say that if we mark here this area, elasticity is less than 1. That means inelastic. Okay. What about at point A, B, C, D, E, E, at point E? We can say that at point E, elasticity equals lower segment is EB and upper segment is EC. And we know that EB is greater than EC. So elasticity is greater than 1. So elastic. So this is also true. This is true for any point between A and C. Okay, so we can mark this as this is elasticity is greater than 1 or elastic. But what about at point C? At point C, elasticity is lower segment is CB, upper segment is 0. Okay, so elasticity is equal to infinite. So here at this point, elasticity is infinity, means perfectly elastic. Okay, now at point B, elasticity is lower segment is 0 and upper segment is PC. So that's why it is 0. Here elasticity is equal to 0, means perfectly inelastic. Okay, perfectly inelastic. So now what is the conclusion in this part? In this part, the conclusion is for, note it down, for point elasticity various point on the same demand curve shows various point elasticity. Okay. What about the conclusion for that? For arc elasticity, various slopes of the demand curve show various arc elasticity. Or arc elasticities. So conclusion is that we have got, so elasticity is del Q del P divided by Q. So for arc elasticity, this is changing, but this is fixed. So for arc elasticity, this is changing. So slope is changing, so they take different slope of the curve, but this remains fixed. For point elasticity, this is fixed and this is changing. Because this is fixed, we have got one demand curve and this is changing, so ratio is changing. Ratio is changing. Okay. Let's see demand curve. Okay, let's see the demand curve. So for demand curve, there are also three types of elasticity. One is called own price elasticity. That means elasticity of good one, price one. So this is del Q1 good one, del P1 1 P1 divided by Q1. So the relationship between own price, that means good one, price of good, good one equals Q1 and price of good one equals P1. So this is called own price elasticity, number one. Number two, cross price elasticity. Cross price elasticity. So that is actually good one, but price of good two. So good two may be good one equals to Q1, price of good two, price of good two, and this good 2 may be T, good 1 may be T, and good 2 may be sugar, either sugar, if sugar and epsilon is 1 3, if 3 is sugar, that means complementary goods, and good, price of good, three is sugar, I mean coffee. Okay, so this is actually del Q1 del P2 times P2 divided by Q1, and this one is equal to del Q1 del P3 P3 Q1. So here the relationship is between tea and sugar, and this relationship is between tea and coffee. So because tea and sugar are complementary, 1 2 is negative for complementary goods, tea and sugar. Okay, so for this, elasticity 1 3 is positive for substitute. Because you see that complementary tea and sugar, so when price of sugar increase, the demand for tea decrease. That's why negative. So when price of coffee increase, demand for tea increase. Both increase. That's why it is positive. Okay. But interestingly, because there is a negative relationship between this Q for own price, only for own price. So there is a negative relationship between QD and price. So there is a negative relationship. We have to take elasticity 1 1 as modulus. Why? Because our range, we have 5 types of elasticity. So elasticity is equal to 1, elasticity is greater than 1, elasticity is less than 1, elasticity is infinity or 0, elasticity is equal to infinity. So you see that there is no chance for negative here. Do you see that there's no chance for negative here? So 1, greater than 1, less than 1, but greater than 0. So 0, 1, less than 1, infinity. So no elasticity 1 1 to be negative. No chance of negativity. So that's why you have to take modulus of this elasticity only for own price elasticity. So take modulus for E11. But for others, you don't have to take modulus, because you see that for complementary good, it is negative. For substitute good, it is positive. Okay. So we have got first and second demand elasticity. Okay. Then there is a third type. It's called income elasticity. Which is y, epsilon y is equal to change in quantity, price of good 1 divided by change in y times y divided by q1. Okay, so for this is actually for 1 unit change in income what is the change in quantity demanded is called income elasticity of demand. So it has got range. Elasticity of demand can be greater than 1. Elasticity of demand can be less than 1 but greater than 0. Elasticity of demand can be equal to 0. Okay. All right. So that means, this also means that for 1% change in income, there is more than 1% change in Q. Can you tell me what is the name of this good? So when your income increases by 1%, your quantity demand for that good increase more than 1%. What is the name of this good? And here, for 1% increase in income, your demand for good one, Q1, good one, increase by less than 1%. 1%. Okay, but positive. So here's second category. This is first category, and this is third category, and this is actually whatever may be the income, there is no change in quantity demanded. Okay. So first one is called luxurious good. Why it is called luxurious good? Because you see that for 1% change in income, your demand for that good is more than 1%. That means you rush to buy that good. So it is called luxurious good. Second category is for 1% change in income, your income increases by less than 1. This is category 4. For 1% change in income, there is decrease in quantity demanded, and that means change is negative. So for second category is called necessary good. Necessary good. That means whatever may be the change, there is some changes, but it is less than 1. And 1 and 2 is together is called normal good. Number 3 is neutral. Whatever change is, there's no change in, so it is called neutral. And number 4 is called, it is of course abnormal. It is called, inferior good. Inferior good. Why? It is inferior good because you see here, this is inferior. inferior. You see inferiority because there's a 1% change in income. Your consumption of that good is decreased. So income here, income increase, Q decrease. So that's why it is inferior good. Here, your income increase, but Q also increase, but less than 1. Q also increase, but change in del Q del Y is positive but less than 1. That's why it is necessary good. But for 1, for this change in Q divided by change in Y is more than 1. Okay, so that's why it is called luxurious good. Okay, all right. Now our last item for today is called supply of price elasticity of supply. Previously we have seen actually let us rename this, not the demand curve, actually it is price elasticity of demand. Price elasticity of demand, and it has got 3 types. Now we are moving to, so this is third. So now we are moving to price elasticity of supply. So again, price elasticity of supply, elasticity is del QS now divided by del P divided by Q. It is arc, and for point elasticity it is dQS dP times P divided by Q. Okay, and this can be shown graphically, and we are going to draw 3 types of elasticity, 3 types of supply curve. So for in the last class we have seen that for C is positive, so if C is positive, C is 0 and C is negative. But for C is positive, we have seen that our supply curve is look like this. So here that portion is C is positive, QS P. Q is 0 means it is passing through the origin, so here, and Q is negative, C is negative, that means there. Okay, so for these 3 types of curve, we will see that there are 3 types of elasticity here. So let us start with this equation. So here epsilon equals del QS del P times P divided by Q. Okay, so let us take the first one. So suppose we have this point. So this point is A. Okay, and this point is B. So here you see that at this point del Q is what is del Q? Del Q is, suppose this is O, and this is actually, this point is suppose C. Okay, so del Q is actually change here, this OB. So del Q is OB. Del P is AB. Okay, times P is AB. So P is AB. So this is P. So P is OP means AB. AB. And Q is sorry. Del Q is not is OB, it is CB. Sorry, CB. Why CB? Because we know that this slope is like this. Okay, so this is slope. So this divided by, this divided by that. So this small triangular is actually proportional to big triangular. So that's why del Q is, this is that, and this is that. That's why CB divided by AB is del Q divided by del C, and AB is price and OB is Q. So if this is the case, then you see that this is cancel out. So CB divided by OB CB divided by OB, and you see that CB is less than OB, and that's why epsilon less than 1. Okay, so for C is positive, epsilon is less than 1, and we know that less than 1 means inelastic. What about case 2? Case 1 is when C is positive. C is equal to 0. So epsilon S is same A, then B, then O. So here, change in del Q, del P is, del Q is AB, sorry, OB, and del Q is AB, then AB divided by OB. So all are cancel out, so 1. So when C equal to 0, epsilon is equal to 1. That means unit elastic. What about this case? So third case. So suppose there is a point A and price is AB. Okay, and quantity is OB, but change in quantity is now, this is actually C. Okay, so epsilon S equals del Q, del P, P divided by Q. Here del Q is OB, del P is AB, times P is AB divided by Q is OB. So AB cancel out, means CB divided by OB So as CB is greater than OB, so our epsilon S is greater than 1. So here for C is negative, that means elasticity is greater than 1 means elastic. Okay. And there are two other types. So similarly, we can find that perfectly elastic epsilon is infinity when it is possible when your supply curve is horizontal. As we have seen in the demand curve case, it is epsilon s is equal to infinity. And whatever the third one, fifth one, in fifth one case, this is fourth one, and fifth one case, when supply curve is vertical, then it gives you elasticity of S equal to 0, because del Q is 0 and del P is positive. Here del P is 0, del Q is positive. Okay, all right. Now, in today's class, we have covered 1.4, we have covered 1.4.1 graphical illustration of equilibrium. We have covered 1.4.2 mathematical model, where we have seen that P is equal to A minus C B plus D Q star, and Q star equal to AD plus BC divided by B plus D. And we have seen that graphically, we have seen this is our equilibrium price and quantity. We have defined our elasticity, and elasticity is del Q del P times P divided by Q, or point elasticity dq dp times P divided by Q. We have seen types of elasticity, two types, two forms, and 5 types of elasticity in supply and demand curve. And we have seen graphical and mathematical representation of elasticity. This ends our today's class, and this ends our chapter 1. So chapter 1 covers basic concepts of economics, then demand, then supply, then equilibrium, then elasticity of demand and supply. So our chapter 1 finished.